We're talking about vectors, 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 vectors. I have a point P, I have a point Q. And instead of a line segment that joins them, I have, what looks like a ray, but what's different is a ray never ends. Whereas a vector definitely ends. It has an initial point, it has an ending point. And so as we look at this vector, we call the initial point, point P, and we call the terminal point, point Q. Now, you've seen Despicable Me, right? Isn't Vector like the bad guy? And he's called Vector because he has both magnitude and direction. Oh, it's kind of a math major joke, I guess. Yeah, yes, you have a great day, sir. So, these have magnitude, and it's the length of the vector. So we have this length of the vector, okay? So the magnitude is the length, and we call it the absolute value of v. That's the length. As you can imagine, vectors also have angles. You can rotate a different way. Okay? We all okay with that basic drawing? Okay. So let's start talking a little bit more about just the geometry of vectors. It says, given the following vector, draw an example of a vector. Okay? So this is vector v right here. Anybody want to guess what negative v is? It's going to look the same thing, just in the opposite direction. What's 2v going to look like? Yeah, same thing, just twice the length. 1/2 v. And negative 4v. So that's my guesstimation for 4 times that in the opposite direction. Hannah, do you think I'm accurate? Okay, I went to you because I thought you would show grace, but she's kind of picking on me, kind of like Third Hour did. So that's all right. I probably deserve it. Gavin is speechless. You think it's that bad? Like you have no comment? You're like, it's that bad, Gans. If I commented, I'd hurt your feelings? Okay, thank you. All right, so now what we're going to do is we have vector A and we have vector B. And we're going to sketch examples of these. We're going to do negative A. Negative A is just going to be the same vector as A, but in the opposite direction like that. And we write negative A. And negative B would be the same vector, but in the opposite direction. A plus B. See, vectors are these occurrences that happen in real world situations, okay? So for example, I used do we have any soccer ball? We got, okay, so say Joseph comes up and he kicks the soccer ball, okay? It's going to have a certain direction to it, and it's going to have a certain magnitude, that being the force at which he kicks it, okay? And it said Gavin running cross country next year, he decides to go up for soccer too. And so Joseph kicks the ball, but he doesn't kick it towards the goal. He kicks it towards Gavin's head, because Gavin is going to then punch it in the goal from there, right? Yeah, maybe. Yeah. Well, with your head. Yeah, your head. Can't use your hands. That's illegal. So, right. So if you look, A plus B is a combination of two things, vector A and vector B. So if I take vector A and vector B, what I'm going to do is I'm going to take vector A, which is that occurrence, and I'm going to put onto it vector B, and that would be the mapping of A plus B. You see that? So like Joseph kicks the ball, then it hits Gavin's head, and it goes over the goal. In the goal. So how we would actually then show A plus B, it would be this result right there, A plus B. So the red vector is the sum of the black and the green vectors. You okay with that? So how would I show A minus B? Yeah, I'm going to use positive A, and I'm going to use negative B. So if I take that and move that up here, notice that this is the resulting vector of A minus B. What? Oh, that's okay. And then we have B minus A, which will be B and negative A. B minus A. And that's how we geometrically do that. Does that make sense? Not too bad, huh? Okay, this is easy. Well, now let's talk about components of vectors. So component form of a vector, you have a horizontal component and we have a vertical component. And instead of using like parentheses or like brackets, we use like the sideways V thing for vectors. And we have A and we have B, where A is the horizontal component and B is the vertical component. And so what we want to do is we want to come up with component forms of vectors, given that it starts at a coordinate of 3, 4 and goes to a coordinate of 7, 5. And this is not rocket science here. You're going to be able to figure this out pretty easily. You just want to show you geometrically what's happening. So I'll go over 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I go over 3 and up 4. 1, 2, 3, 4. And I go over 7 and up 5. Does everybody see that vector? So if I took that vector and I translated it to the origin, how far does it go over? One, 2, 3, 4. And how many does it go up? 1. Everybody see it goes over 4 and up 1? How did we do that? Watch. 7 minus 3 is 4, and 5 minus 4 is 1. So that is the component form of that vector. 4 units to the right and 1 unit up. And so when you see a component form of a vector, what it does is it takes a vector that maybe used to sit in space, and it pulls it right down to the origin. And when it's at the origin, it's just easier to work with. Okay? So all we have to do is subtract the x values and subtract the y values. So if I want to come up with component form of the vector here, I simply do 4 minus negative 3, which is 7, and then negative 1 minus 2, negative 3, and that's component form of the vector. Easy enough? Cool. Flip it over. So now we're going to discuss magnitude of a vector and the direction of a vector. So the length of a vector, let's see if you guys can figure this out. I have a vector that sits at a location of A, B. That's the component form. That means I went over A and I went over or up B. Can anybody think of a way I could come up with the length? Yeah, the magnitude of a vector is simply the square root of A squared plus B squared. Does that look familiar? Have we done that before? Yeah, so we're just taking what we've done before and applying it to an interpretation of vectors. And then, obviously, there's an angle that sits between. Anybody want to think of a formula that we can use to come up with the angle? Let's just use tangent of theta is equal to b divided by a. Have we done that before? There you go. So we're going to find the magnitude of each vector and the direction. The magnitude of this vector, and notice we write it as the absolute value. That means its distance from 0. That's what we're talking about, okay? The magnitude of the vector is going to be the square root of what? Yeah, which is the root of 29, isn't it? And I want to find the direction, so I do is equal to b, which is negative 2 over 5. You help me. How do I determine theta? Inverse, but which quadrant am I working in? Why the fourth quadrant, Patty? Over 5 down 2 puts me in the fourth quadrant. So I'm going to tangent inverse 2 over 5. Tangent inverse 2 divided by 5. Boom, 21.8. So that's not my answer. My answer is not 21.8. How would I determine my answer? Yeah, 360 minus 21.8, and I think you get 338.2. Let me show you guys. Yeah, you sure can. Let's look at an easy way to do a problem. 0, 3. So I'm not even going to do this work. I'm just going to look at it and say, what's the magnitude of the vector? 3, right? Has a length of 3. What is the angle? 90 degrees. See how nice that was? Not every time. Like the next time, we've got 3, 4. So you know that vector is over 3 units and then up 4 units. So if I want to find the magnitude of the vector, I have to do the square root of 9 plus 16, which is? Yeah. Oh, it's a 3, 4, 5 right triangle, right? Yep, that's why I paused the video. Okay, here we go. So I've got a 5 here. Now I need tangent of theta is equal to what? 4 over 3. I'm in the first quadrant, right? So that's going to make this easy. I just tangent inverse 4 divided by 3, and I get 53.13 degrees. Please tell me that when you get to these parts of the test, you're like, hey, I may not be able to do de Moivre's theorems or nth roots of complex numbers, but I can find the angle and the magnitude of a vector. Yeah. These are the points you want to get, okay? All right, sum and difference of vectors. Really quite simple. If vector A is 1, 3, anybody want to guess what 3A is? 3, 9. Let's go. If vector B is 2, negative 2, anybody want to guess what 4B is? Sometimes I can't do the computation in my brain because my brain is small and weak. So if I have to do A plus 2B, I take vector A, which is 1, 3, and I add to that, as Miss Ella said, 4, negative 4. Anybody want to guess how I add vectors? Well, 5, negative 1. I've got an idea. How about you try the next one on your own? On your mark, get set, go. Nope, we all right, here we go. What'd you get here? Good. Any questions on that? So vectors used to be expressed in terms of I and J, and I don't know why. I don't know if they used to have like limitations in their like typewriters and stuff like that, where they couldn't like write these symbols like A. Oh, sorry. So like let's say like CD. say like vector CD, for example, okay? And so sometimes vectors are expressed like this. They're expressed as CI plus DJ, okay? And sometimes that's how people express them. There's no difference between them really. It's just it's what it is, okay? So what we want to do is we want to figure out how to come up with the horizontal and vertical components of the vector. And for that, I'm going to have to go to no, you just go away. Go away. And I'm going to have to go to this screen, and you guys are going to help me figure this out because you're extremely intelligent. We've already been over that many times. I have a vector AB. And so that means that this distance is what? A, and this distance is B. Good. And I have something called the magnitude of the vector right there, and then I have an angle. So what I want to do is I want to come up with a trig expression that involves magnitude of V, theta, and A. Cosine, good. So cosine of theta is equal to A over the magnitude of V. So if you want to try to come up with the horizontal component, or A, simply multiply both sides. You get the magnitude of V is times cosine of theta is equal to A. Look at that. Suppose I want to come up with the vertical component, which is right here. Sine, good. So sine of theta is equal to B divided by the magnitude of the vector. Multiply both sides by the magnitude of the vector, and I get magnitude vector times sine of theta is equal to B. So you can see that these two will be used in order to come up with that. So if we go, yeah, we're going to write it down. We're going to write it down. We'll write it down. We'll write it down. Don't worry. So when we get to this part where it says horizontal and vertical components of a vector, the horizontal component is is the magnitude of the vector times the cosine of theta. And the vertical component is the magnitude of V times the sine of the angle. And hopefully now you can start to see why trigonometry is incorporated with vectors. We've had a squared plus b squared is c squared. We've had tangent of theta is b divided by a. We now have sine and cosine. We're covering the full gamut.
Can you scroll up so I can get
Sure thing. How's that?
greater than or equal to?
This thing?
Yeah.
It's like an arrow. It's like that means that.
Oh, like a strong arrow?
Yep, yeah, sure. You do you. This is a plus sign.
Oh, yeah. Oh, C times I plus D times J.
Yep. All right, so express the following vectors in component form and in terms of I and J. So what we have is we have a vector of magnitude 3 and at an angle of 30 degrees. So we're wondering what is the component form of the vector. That's what we want to know. And we have a formula. A, which is this value, happens to be equal to the magnitude of the vector, which is 3, times the cosine of the angle. And then we have B, or this part of the vector, is equal to 3 times sine of the angle. So all I need to do is figure out the cosine of 30 and the sine of 30. Cosine of 30, root of 3 over 2. Sine of 1/2. Sorry about that. Sine of 30, 1/2. I'm dumb. All right. So you can see that our component form is 3 roots of 3 over 2, comma 3 over 2. Now, if you were to write it in terms of I and J, all that would look like is 3 roots of 3 over 2I plus 3 over 2J. Again, I don't know why your book has you kind of look at that, but again, maybe it was back in the day. I don't know. Whatever. Try the next one on your own. I'll see if you can come up with the component form for magnitude of 4 and angle of 315 degrees. Go. These are the things that keep me up at night. Okay. So you should have 4 times the cosine of 315, and then 4 times the sine of 315. And 315, the cosine is going to be root of 2 over 2. And sine of 315 is going to be negative root of 2 over 2. So notice that you do get, in this situation, positive 2 roots of 2. And in this situation, you get negative 2 roots of 2. And if you were to write it in IJ form, I think you know how that works. Flip it over. We are almost done for the day. Magnitude and direction of each vector. We've already covered this once. I just want to set them up to make sure that you understand. If you were going to find the magnitude of a vector, again, what would you do? Square root of a squared plus b squared. Can we all agree that you know what to do from that point? Okay? And if you want to find the angle, you would do tangent of theta is equal to, yep, negative 2. And do we know what to do at that point? Okay, if you look at the next one, magnitude of the vector would be equal to the square root of, now we just got a little bit more complicated. What do you get if you square the root of 3 over 3? 3 over 9, which is 1/3. And what do you get if you square negative 1? 1. So you would have to deal with that, right? Okay. And then please watch this. When you found the angle, you'd have tangent of theta is equal to the b value divided by the a value. Now, since this is not your final answer, you could just type that into the calculator. But if you were going to try to resolve this a little bit, instead of dividing by a fraction, I multiply by the reciprocal. So this would be times 3 over the root of 3, and you would get negative 3 over the root of 3. And we do not leave a radical in the denominator, do we? So multiply top and bottom by the root of 3, which I think is one of the dumbest rules in math personally, but negative 3 roots of 3 over 3. Notice how those cancel, and you just get negative root of 3. And then you can work from there. So just want you guys to see some of the challenges that may result in your arithmetic. So let's see where we're going to use this in the real world, okay? Gavin is out pushing the lawnmower around. Gav, do you mow your lawn? Okay. You got a push mower, riding lawnmower? Push. Is it gas or is it electric? Okay. All right. Low maintenance. So Gavin is out there. All right. He's having a bad hair day, but at least he's having a hair day, unlike some of us. Okay. All right. And, you know, Gavin is, he's got this lawnmower. Okay, that's his lawnmower. And he's cutting some grass. Okay, he waited a little bit too long. Not because he was lazy, because the Hankey family doesn't know the meaning of that word, right? Okay, I don't know. It seems like something for Maya. Okay, no, I'm kidding. So he's ready to go. But you know, let's say that the lawnmower weighs, I don't know, 50 pounds. Okay, if he's pushing the lawnmower, okay, all right, as he's pushing the lawnmower, his effort that he's pushing with, is that all going straight into the ground? Some of it's going sideways, right? Right? So it's kind of like, well, how much weight is the ground feeling? It's feeling more than 50 pounds, right? Because like he's pushing, but he's pushing at an angle. In fact, it says that he pushes with a force of 24 pounds. I just made it up. It says that the handle forms a 40-degree angle with the ground. It says find the horizontal and vertical components of the force. And what that means is that some of the force is going straight down to the ground, and some of the force is going horizontally, right? So that's the vertical component of the vector, and that's the horizontal component of the vector. What formula do we have to compute the horizontal component of a vector? Good. 24, the magnitude of the vector, times the cosine of 40 degrees. I go ahead and I take out my calculator, and I've got 24 times the cosine of 40. And I press enter, and I get 18.38. That means that those 24 pounds of force that he's applying, 18 pounds are going in the horizontal direction. So obviously, it doesn't take 18 to push the lawnmower. It's on wheels, but that's determining kind of his speed, right? So if he was applying, say, 30 pounds of force, it would be going faster, right? Okay. Where if he was only applying 1 pound of force, it might not move at all, right? Okay. Now, if we compute B is the vertical component of the vector. We have 24 times the sine of 40. Okay? So he goes in here, he goes 24. He's taking a break. He's like, getting a Kool-Aid or something. Okay? And he's got 15.43. So the component form of his vector is 18.38 and 15.43. And what that means at that point is you can see that the vertical component of the vector is 15. So the ground is actually not feeling 50 pounds of weight. The ground is feeling 65 pounds of weight. Get my point? And that's important. Just to end, my father, he was working